Hello, I'm James Donaldson, partner at Johnson Fain, and I'll be speaking about Figueroa 8 Advanced BIM Techniques for Designing a Signature Residential Tower. Johnson Fain is founded by Scott Johnson and Bill Fain, and we're located in Los Angeles. And we practice urban design, planning, architecture, and interiors. I wanted to start with a slide of the overview of the building so you can see the whole picture. It is a residential tower in downtown LA on a corner site. And I will be focusing on the facade and the BIM coordination and the programming that is involved with delivering this kind of facade on a residential tower. For those of you who are not familiar with Los Angeles and where this is located, LA is in California on the west coast of the United States. Figueroa 8 is the midpoint between a educational and entertainment district to the south and a financial core to the north. So it's kind of right in the middle. And it's on a major nexus of transit lines. Some facts about the project before I get into the BIM. It's a 41-story tower, 500 feet tall. There are 438 units, 500 cars, 226 bicycle, and it has a commercial space on the ground floor that activates the street. Mitsui Fudosan America is a great client. And for this conversation, we'll be focusing on Lend-Lease, who's the contractor, and Vision Systems, Inc., who is the facade manufacturer, and GlueMac, who did the MEP and energy modeling. When designing, you have to take in consideration of the durations of time. So time is important to consider. The entitlement period started in 2016. The project started construction in 2020. There's 4 years between there. So when you're doing BIM work, when you're setting up a project, be considerate of these long durations when designing large scale projects and the complexity of different packages and different points of delivery. The data has to respond to this. So the parameters of the project that I like to start off with are the double story expression. This is an idea that we came up with early, and the double story expression creates a different detailing at the odd floor and at the even floor. The two modules that we played around with are a 5-foot module, which is a very rigorous module to work with the unitized system, but we made a submodule of 2.6. And the expression of the vertical was important. So the mullions have a mullion cap on them, and that is a particularly unique thing for Los Angeles. In the other parts of the world, this might not seem like a big deal, but in LA, there's a requirement we have to capture in the horizontal. So we had to achieve a special use permit to capture in the vertical. And the last parameter are 4 glazing treatments. We're all familiar with clear glass, and that's what we call vision glazing. But we also have vision glazing that has a dot frit on it. The dot frit helps with shading coefficient and lowering that down. So it's an energy performance mechanism. Spandrel glazing is the same as vision glass, but it has a film on the back that is opaque, so nothing passes through the glass. This is where you basically blank out a panel, but it still looks like glass. And then we have a 4th type, which is spandrel glazing with a dot frit, so it has a companion with the vision glazing with dot frit. So in summary, we have a double story expression, we have 2 modules, we're expressing the vertical, and 4 glazing types. When I say a double story expression or 2-story expression, there is this articulated slab edge cover on the odd floors. And then there's just a line of glass, a shadow box on the even floors. So there's alternating details. So the BIM data is actually alternating per floor. So the project has a design goal. It's a very kind of classical, simple point tower, but there's a nuance to it that is a very elevated facade system that has sophistication of a kind of pattern language that is expressed through detailing and through the glazing and is set within a kind of classical order. What that means from a BIM point of view is you're creating data that's going out to the render artist. It's going out to the client. It's going out to the contractor. It's going out to the mechanical engineer. It's going out to all the consultants. You're using it for presentations. You're driving the data internally, and it needs to be managed. The same data needs to be managed and constructed that it can meet all these expectations. So the way that we look at this is we look at it on a per floor basis, and each floor has a set of window bays, I'm going to call them. That's basically a collection of these modules. But each bay is a stack of panels. So taking a big building, breaking it down per floor, per bay, per stack was our methodology to govern the BIM data. So our logic is always going to start at the stack and go back to the building. And that's how we're going to speak about it to the contractor, to the energy modeler, to the consultants, and to the fabricator. So I've shaded out the balcony in the corners. We'll take those off the table for this conversation. It's complex enough as it is. You have a left, right, and center bay, and they have the rigorous 5-foot module. Those dimensions are very set and were coordinated early and not to be modified. So then within those 5-foot modules, we have a and a B. The A is always stacked on the B, and those need to go together and be read as a vertical line. So you always have to have continuity from data from B to A, which are the stacked modules. But A has to take in consideration of that articulated slab edge cover, whereas B has to be set above that, but also take consideration of the recessed slab cover, which is the glass shadow box. So the software that we're using for this at this point is Revit. Our studio does start off with other softwares. It could be Rhino, SketchUp, but we go into Revit very quickly because now we're in schematic design and we're starting to build a set of data that can transcend through construction. So system panel A and B are native system curtain wall system families. So then you go into the Revit family, which is a curtain wall panel. The curtain wall panel has a nested family, which is the elements. I think an idea is the movie Inception, where you find the main character living a dream within a dream. So what's happening here is this is 3 dreams deep. So you have the nested family, which goes inside of the Revit family, which then goes inside of the system family, which is in the project. So you're 3 dreams deep in this scenario. So the data has to go through 3 tiers of levels, 3 tiers, and you have to be able to schedule that, count it, and filter it. So looking at a stack, it could be like 2 5-foot modules over top of each other, or the 5-foot modules are sub into 2'6", and there might be a solid and a clear, or a spandrel panel and a clear. And then the vertical stack could have a window, has elements, a vent, a window, and it has all these variables of clear and solid. So the Revit family has to have common points and common data that is then distributed everywhere. So what you're looking at is a shared origin for the nested families. Then you define the variables in that Revit family that's going to be uniform. And those variables are at the top, there's a kind of a top of panel, which is the mullion offsets or the shadow box height. And then the window, right? Because if the panel is at the belt, the window is slightly lower relative to the panel dimension. And if it's at the slab, the window is a little bit higher relative to the panel dimension. And the other analogy I like to look or to use in this scenario is having panels that are nested are like little parts, and you have all these parts and you put them in a bucket, and you reach into that bucket and you pull out the part that you need in this assembly. So we only have a few parts. One is a glass panel that can be glass, or it can have the shadow box or spandrel on it. The other is a mechanical vent, which I'll talk about fresh air and exhaust in a minute. And then the curtain panel window, the operable window. These are the three little parts that we have in our bucket that we're going to reach down and grab and pull out and use when we need to use them. So now that I'm in the Revit family, I'm going to reach down into the bucket and I've pulled out a clear glass panel that has a shadow box. So you can see here, the first thing to focus on with BIM data is the type name. We use shorthand, but it needs to be intuitive. CWP is our office standard for curtain wall panel. That tells you where this Revit families come through in a typology point of view. This panel has a window on it. This panel has vision glazing, meaning it's clear glass on it. Then the next universal filter is a location, and these are instance-based. So that means every panel that's installed, we can decide what orientation, north, south, east, or west. So it's an instance-based parameter so that when it's in the project, we can program all the north panels to say that they're pointing north, and that helps with scheduling and giving data back to the energy modeler. Then there are driving parameters. This is where you reach into the bucket. These parameters go in and reach in the bucket, and they pull out nested families and swap them out around that shared origin. They change and cycle through and drive the switching out and also the materiality. And that brings me to the last one, which is a type comment. We filter this and graphically with a code GL1, which means glazing 1, which is actually the same information that's in our material schedule. So the contractor is reading the same information that's the BIM data that's driving the Revit model. I've advanced the slide, and you might not have seen it, but you see on the right, the color of the glass went darker because this is the vision glass that has GL2 has a dot pattern on it. This one is a clear vision shadow box, and that's a GL3. And the last one is a shadow box that has a frit pattern on it, which is GL4. Again, GL4 is what the contractor knows as shadow box or spandrel panel with dot frit. So coming back to Revit families, this is a series of set of families. Again, just remember the naming has to be clear and intuitive. So we have family types that have these set of names. We are driving the materiality of the mullions so we can change the color from a design point of view. We've locked certain assets as we've made design decisions about the location of everything, and we've determined which panels are full height and not full height, and we just have a series of data that you have to set within the Revit family that will be scheduled. So coming back around, this allows you to each bay have multiple options. So on this one bay, you have two different reads, even though the unit behind is the same. You can see the window kind of bounces back and forth from left to right around that 1 million. You can see the glass pattern where the dot frit moves around. You can see that the little horizontal, which is the mechanical vent, changes, whether it's a 5-foot or 2-foot 6 panel. So these are the variables that you can play with to make different patterns, basically. And so then we took that and made a pattern set because the contractor wants to see things repeat. And you want to reduce that kind of pattern set. So pattern 1, pattern 2, pattern 3, the unit behind this are the same, but the patterns are different. I will say that the red is actually the same vision glass as the light blue. It just is vision glass with dot frit. So these filters were also used to coordinate with the mechanical engineer. So now we've color coded the fresh air intake and exhaust and coordinated that with plan. And that way we're using graphic tools that people can read in the model or in 3D or when printed, so they understand how they can coordinate their work. So the window to wall ratio is where we're going with all this. Working with GluMac and their engineers for energy modeling, we took this design and we're able to create a graphic that visually summarizes the building by orientation of where clear and vision are and spandrel with dot are. Then we extract that into Excel utilizing third-party add-ons, and we are able to collect everything by where it is on the building and by its orientation and feed that to the energy modeler. It really has helped with taking a complex project and simplifying it to achieve the strict energy codes that we have in the state of California. Now, that's a lot of information, but in truth, there are 12 panels. They're stacked, and this kind of A over B, but there are 12 sets to choose from. They go from a 5-foot down to a 2'6" for some odd locations, and they have windows and mechanical vents, and we indicated where the shadow box had to occur to conceal the floor slabs. So the contractor can understand that schedule, which is derived from the Revit family. Then we were able to show that on the left, we met that kind of classical organization with this subtle, sophisticated pattern through pattern sets are repeated. So you can see like pattern set 1 repeated 3 times, 4 repeated 4 times, 5 repeated 3 times. So reduce the number of complexity in the project. I want to bring into real world truths here about how the design process works with those who are building the project. So we start with advanced BIM. This might be Grasshopper, Dynamo, and during schematic design, and that's our internal design team can really elevate the project to deliver high data, big volumes. But then as you bring all the teams and everybody has different backgrounds and knowledge of software, you simplify that BIM data down to what is really needed at the project and around the decisions that have been made with the engineers and the fabricators. Then construction starts, and you start communicating through organizational tools, which for us is Bluebeam. This is basically marking up a PDF in a 2D methodology, and I'll show you how we did that with engineering the project to save money and elevate the fabrication process. And then the people who are building the building have submittals that are also PDF that you review and return and coordinate. So here's an example of how there was a request to reduce the amount of panels and the complexity, and we responded with, yes, we're happy to do that. And we utilized Bluebeam and Excel to quantify it, and then we altered the glazing typologies to meet energy standards and work with energy modeling to redo the energy calculations. The fabricator produced the fabrication, and it all kind of worked seamlessly. So in summary, this is the project. 1 is the clear glass, 2 is the spandrel, 3 is the spandrel with fit, 4 is the articulated slab, 5 is the clear slab, and 6 is the mechanical vent, and 7 is the express vertical. Patterns repeated through the building. Now you see this image again, and you understand how it's set into this dialogue of a tall building. And Figueroa is open in downtown Los Angeles and fully built out as a residential building for rent. And I am James Donaldson. This is my Instagram handle and my email, and you can scan this QR code. I will be around today in the lounge, and I would like to continue the conversation. Thank you very much.